question for all the panelists. How can collaboration between industry stakeholders, example, manufacturers, engineers, and contractors, drive innovation in waterproofing for sustainable infrastructure? I pose this question to all the panelists, starting with Mr. Popat.
See, what we are doing right now in Waterproofers Association of India, we are doing such collaborations of applicators as well as the manufacturers, and we are also collaborating with developers so that all three of them to come together and form a proper specifications. And we are tying up with Naredco, we are tying up with other real estate developers so that we can make a cohesive specifications and proper workmanship which is available in this thing. And through CIDCC and IITD, we are getting trained applicators also who would be ready for doing the jobs. So the Naredco, and we have tying up so that they will use the applicators from the trained IITD as well as WI, and can benefit from that.
Thank you, sir, for sharing those insights. So, Mr. Sunny Sarkar, can you share your insight?
But nobody is talking about like how a waterproofing will integrate into your building system, right? So that is the primary problem that I think most of us people from both the application side as well as the material supply side we face. So there has to be a system whereby waterproofing is integrated into the building designs right at the construction stage. So we do that for certain projects. It's not absolutely not there, but maybe say only about 4 to 5% of the projects today that we see are doing it. So we are working with the structural engineers as well as the architects to integrate the waterproofing, say for the basements or for the roofs during the design stage. So we say, okay, this is once your structural design is over, you decide the waterproofing, what kind of systems will go on. It can be from A, B, C, D, E company. That's doesn't matter. But these kind of protective things are needed. Then the second part of it is what I talked about. There is no, like say, nobody asks what is the quality of the building before we start waterproofing. So there will have to be some kind of a thought process going forward. Like how do we ascertain whether the building itself meets its structural requirements? See, waterproofing is something made to just protect from water, right? But nowadays we see that, the building moves or the basement moves down. There is large scale cracking. Then slabs move. Post tension slabs are supposed to have like a crack width of maybe 0.3. They open up to 2 millimeters. So pretty much whatever kind of waterproofing you do in that situation is bound to fail. Doesn't matter you're doing a polyurethane, a polyurea, a preform membrane, these kind of things happen. So the point is, who is going to be talking about what kind of things the building, what basic performance requirements are to come from the building side, whether the building itself is stable enough to accept a waterproofing treatment. So that is another part of it. And then, of course, you have your material people, your application people taking a look and working together to decide what kind of waterproofing can be executed given the site conditions. Like, some sites may be submerged, some sites may be this one. So what different kind of things are required to be done to kind of make sure that you can do the waterproofing effectively. So it is something that the industry has to take steps with. I think what Mr. Kunjjaan said, we have to work with both the building side of it, the consultancy side of it, as well as the materials and the applicator. When you have this four-pronged approach to taking a look at waterproofing, I think we should be able to develop much more leak-free buildings in the future.
Thank you, Mr. Surlaker. Mr. Padmakar, you want to add something on this?
This is an educated platform for education to our listeners. I'm quite sure that the people who are attending this on the other side of the table, they would want, because net zero is a subject which is coming today. It's going to come in to the world today or tomorrow. It's going to happen because we are getting worse day by day as far as the built-up environment is concerned. And therefore, building envelope, net zero, the replenishment through non-conventional energy resources other than fossil fuel is going to come into place. So this is my take on this. I don't have anything more to say. Thank you.
Thank you, Mr. Padmakar. Miss Viha, can we have your take on this?
So basically, yes, definitely there is a sync missing between the one who actually makes or manufactures the material, the one who is going to apply the material, and the one who is going to specify a material. So, in very common words, you can describe it as I'm using one dictionary, the applicator is using another dictionary, and the specifications guy is using an absolutely different dictionary. So, as Sunny sir highly, mentioned correctly, that one person is talking about it should cost so much, one person is restricting on the time part, one person is restricting on the what you can call as the interquote interval part, one person is focusing more on the warranty guarantee part. So there is no one sync, like everybody has different priorities. So when you have different priorities, there is absolutely an off sync. Still, at Kangaru Polymers, as we call ourselves as not just manufacturers of waterproofings and coatings, we label ourselves as solution providers more than that. So we are taking our small steps, like, giving checklists or, documents like method statements or the proper consumptions, and what needs to be really focused on and what, can be the secondary part. So we are trying to get in some kind of standardization which can help that everybody can be on the same platform to expect a good waterproofing solution. So that's the ultimate goal. So to achieve that goal, everybody should have a common priority list. That's my insight. Thank you.
Thank you, Ms. Viha, explaining that. My next question is for Mr. Padmakar. Can hybrid polyurea applied from negative side, and how much water pressure it can take when applied from negative side?
From negative side, you cannot apply hybrid polyurea.
Okay.
Normally, most coatings cannot be applied except to a certain extent, if there is the pressure can be taken, it can be a concrete leakage that can be applied with, as Mr. Kunjjaan said, with a crystalline coating or something like that. From negative side, nothing can be applied. And it's foolish to think that it can be applied to a certain extent, depending on the kind of pressure or the kind of penetration. The solution will have to. That is why, otherwise, Mr. Kunjjaan, why will he explain so much about injections? If negative side membranes will work, So Mr. Kunjjaan's premise today was all because of that.
It's not possible to do any membrane coatings except for crystalline, which basically crystalline is the material which yeah, I think Sunny will say more on it. But crystalline is something which impregnates into your concrete structure, and maybe it stops water at that point.
Yeah, mild leakage, it can stop. So injections is the only way you can, and that too is post-construction. You cannot do new construction and apply a waterproofing and say that it will work for negative. That is why I was showing in my slide an unconfined retaining wall. I mean, a confined retaining wall, that means the blind side waterproofing, where you put a membrane on the shuttering and then cast concrete, So therefore, that will stop. And that too, there are a lot of protocols and methods of how to apply it. There are 3 or 4 categories of membranes in the world that come into that. Bentonite waterproofing is one of them. Like Setco has got it because I've applied it a lot in salty water in West Africa, in the Atlantic Ocean. So there are certain categories of membrane. Negative side se kuch kam nahi karta aisa. Only injections and, so stuff like that.
If I can just add to that, like say oftentimes there is, I would say, a very wrong product expectations. Things like people expect a lot out of different things. Ki log ke udhar pura basement mein water is coming in at full force, or with lot of pressure, and they say, okay, can you apply crystalline coating and solve it? No. So like many people say, oh, it has got a crack sealing or self-healing capability. So many people can't visualize it. Like the self-healing capability is 0.4, 0.5 mm, which is like hairline, as much as 2 strands or 3 strands of your hair. So only if the cracks that small inside, it heals it. But if there is a large structural crack coming through it, it is not going to stop that water. So in that case, your specification does need to have like the injection part of it, then the repair part of the wall, and then you go ahead and do your crystalline system. So that is the kind of work steps or the work methodologies that need to be, made very crystal clear to the client in managing client expectations. Client expectation is do whatever, apply a band-aid to it, and there should be no water for the next 10 years. But that is not really how, that's not how engineering works, unfortunately.
Thank you for answering that. I have one more question for Mr. Padmakar. How do we compare the life of TPO versus acrylic coating? And will acrylic coating last more than TPO?
See, TPO is a highly lasting membrane. For example, the Bombay Airport TPO is around 90 mils thickness. Okay. And it was applied much before the inauguration of the Bombay Airport. There's no doubt that reinforced TPOs will work for a long time. The only issue with reinforced TPOs is that if there is any damage, the entire TPO will have to rip it off and applied again, which is a huge cost. Versus that, very high quality liquid applied membranes, are also high lasting. The advantage there is that you can buff it and add another coat. There are the high-end coatings, that is how they help the customer to recoat it, in an interval of anywhere between 5 to 7 years or even 10 years. I know a coating that has been applied on a particular structure which is around 17 years old. So they have just buffed it and just put the top coat again. So there are a lot of technologies in liquid applied coatings. You got a lot of options. So this is my answer for that.
Thank you, Mr. Padmakar. My next question is for Viha ma'am. What properties should be there to select primer for different substrates?
Okay, so majorly liquid applieds will be applied on either a metal roof or most conventionally a concrete system, or extreme on an existing coating. So these are major three areas where the liquid applied membranes can be used. So for metal roofs, we suggest using a polyurethane primer. So generally a single component primer can be used on the metal roofs. And otherwise on concrete surfaces, if you're chosen an acrylic system, then you go in for a water-based primer. And if you're going for a PU or an epoxy system, then yes, there are epoxy primers available. Epoxies are generally two component primers. Then there are polyurethane single component primers available. And we fortunately have specialized primers as well in our product basket. So we have one moisture tolerant primer, which I mentioned briefly during my presentation. So that primer accommodates approximately 12 to 14% of residual moisture. And yes, one very important thing that should be present in your primers is the adhesion promoter. So if the adhesion promoter is present, so it can, seal the surface very properly and it can adhere on the either side. Generally, people will have ideas saying that what if we dilute the acrylic system with water and, just use it as a self-priming thing. So we suggest that don't please do that, because there is no adhesion promoter present in the coatings. The adhesion promoters are generally present only in the primers. So yeah, that's my answer to that.
We have one more question for you. What advantages do liquid applied membranes offer over traditional waterproofing methods in terms of sustainability?
In terms of sustainability, yes, as I already mentioned in my first slide, that the sustainable waterproofing, you can consider that it can have more dead load. So the chemical or the liquid applied waterproofing, it will give a very less dead load, very negligible. The thickness will be minimal. Then there will be no joints, and as I mentioned again in my slides, that you get good quality acrylic systems in the market these days. You should just check for 3 to 4 things like the solid content, the elongation, the tensile, and use a proper fabric reinforcement. So what it will do, it will give you a very good ROI on the system. For example, if you install the system today in 2025, if it is installed properly, it will definitely last up to 10 years from now. So that will not be a problem. The only issue is that you should use it properly and you should choose a good quality product. So it is more of an investment rather than a cost. Waterproofing should be seen and measured in that way. Yeah.
Thank you, ma'am. Mr. Sunny Surlaker, how can technology such as BIM improve the implementation of waterproofing specification?
See, BIM is just a building information modeling. Like when we talk about it, it's more like I would say, a project management tool. But that doesn't help to, I would say, implement the specification. The specification, technical specifications have to be drafted up between the technical team and this one. What BIM can help with is to make sure whether, the checklists that are done, like say every waterproofing system that you do, whether for a basement or for a bathroom or a terrace or whatever it is, there will be a certain steps, a certain set of steps to do it. And that checklist, whether it is complete or if it is incomplete, like whether that data, once it gets fed into your BIM, so it will just help you kind of maintain the records for one. And second is that it will help you to kind of have a visual view whether everything was done according to what is written in the document. Like, one of the key things that in waterproofing, I'm very surprised that nobody asked that question or came up with it, is like, say when we're discussing all these things, whether it's liquid applied membranes or the polyurethanes or the coatings of different types, there wasn't any questions or no sort of thought process given to it. Like, people are not asking what is the thickness that you require out of these systems, for example. That comes as part of the specification. So many people, they say, oh, let us compare a TPO, or I think there was a question there, right? Compare a TPO and an acrylic. So now a TPO membrane, if you see, typically is 2.5 millimeters. I'm pretty sure if you make an acrylic coating that will go up to 2.5 millimeters, it will last as long as a TPO and probably longer. But generally, what is being compared is like you put a 2.5 TPO membrane and you apply, say, maybe 1 kg of an acrylic, which will give you 500 microns. And then you expect it that it lasts for the same time. So that it doesn't work like that. So all these things, they become part of the technical spec. Like each and every coating, when you specify, there has to be a minimum thickness at which that coating becomes functional. So whether it is cementitious, then it's at 2 acrylics at about 1 to 1.5 polyurethanes, polyureas, and the like at somewhere close to about 1.5 to 2 millimeters. So that is kind of the break-even point where you need to do, and a proper specification along with that data, like what consumption to use. I think that will pave the way forward to, like, how to use the material in the right way. So that is also something that the BIM is one of the things they can check up is or they can document is whether the right consumption of the material has been used. It can track a lot of those kind of data, so that would be very helpful.
Okay, thank you, sir, and thank you to all our esteemed panelists for this enriching discussion. Your insights have provided a roadmap to sustainable leak-free infrastructure in India's net zero future.